In algebraic geometry, the Cremona group, introduced by Cremona, 1863-1865, is the group of birational automorphisms of the n-dimensional projective space over a field K. It is denoted by Cr, Pn, K, or Br, Pn, K, or Crn, K. The Cremona group is naturally identified with the automorphism group Autk, K, x1, xn, of the field of the rational functions in n indeterminates over K, or in other words a pure transcendental extension of K, with transcendence degree n. The projective general linear group of order n plus 1, of projective transformations, is contained in the Cremona group of order n. The two are equal only when n equals 0 or n equals 1, in which case both the numerator and the denominator of a transformation must be linear. The Cremona group in two dimensions. In two dimensions, Max Noether and Castelnuovo showed that the complex Cremona group is generated by the standard quadratic transformation, along with PGL 3, K. Though there was some controversy about whether their proofs were correct, and Gizatelan, 1983, gave a complete set of relations for these generators. The structure of this group is still not well understood, though there has been a lot of work on finding elements or subgroups of it. Cantat and Lamy, 2010, showed that the Cremona group is not simple as an abstract group. Blanc showed that it has no non-trivial normal subgroups that are also closed in a natural topology. For the finite subgroups of the Cremona group, see Dolgachov and Iskovsky, 2009. The Cremona group in higher dimensions. There is little known about the structure of the Cremona group in 3 dimensions and higher, though many elements of it have been described. Blanc, 2010, showed that it is linearly connected, answering a question of Serre, 2010. There is no easy analog of the Noether-Castelnuovo theorem, as Hudson, 1927, showed that the Cremona group in dimension at least 3 is not generated by its elements of degree, bounded by any fixed integer. De Jonquières groups. A de Jonquières group is a subgroup of a Cremona group of the following form. Pick a transcendence basis x1, xn for a field extension of K. Then a de Jonquières group is the subgroup of automorphisms of K, x1, xn, mapping the subfield K, x1, xr, into itself for some Rn. It has a normal subgroup given by the Cremona group of automorphisms of K, x1, xn, over the field K, x1, xr, and the quotient group is the Cremona group of K, x1, xr, over the field K. It can also be regarded as the group of birational automorphisms of the fiber bundle PR times PNR. When n equals 2 and r equals 1, the de Jonquières group is the group of Cremona transformations fixing a pencil of lines through a given point, and is the semi-direct product of PGL2, K, and PGL2, K, T. Alberic Karamanana, Maria, 2002. Geometry of the plane Cremona maps. Lecture notes in Mathematics. 1769. Berlin, New York. Springer Verlag. DOI. 10.1007, B82933. ISBN 978-3-540-42816-9. Mr. 1,874,328. Blanc, J. Acute R. Acute My. 2010. Groups de Cremona. Connexité et simplicité. Annales scientifiques de l'école normale supérieure. Quatrimi série. 43. 2. 357-364. ISSN 0012-9593. Mr. 2,662,668. Cantat. Serge. Lamy. Stéphane. 2010. Normal subgroups in the Cremona group. Arxiv. 1007.0895. Coolidge, Julian Lowell. 1931. A Treatise on Algebraic Plane Curves. Oxford University Press. ISBN 978-0-486-49576-7. Mr. 0120551. Cremona, L. 1863. Sulla trasformazioni geometriche del figure pian. Giornale di Matematiche di Battaglini. 1. 305-311. Cremona, L. 1865. Sulla trasformazioni geometriche del figure pian. Giornale di Matematiche di Battaglini. 3. 269-280. 363-376. Demazza, Michel. 1970. Sous-groupes algebraiques de rang maximum du groupe de Cremona. Annales scientifiques de l'école normale supérieure. Quatrimi série. 3. 507-588. ISSN 0012-9593. Mr. 0284446. Dolgachov, Igor V. 2012. Classical Algebraic Geometry. A Modern View. PDF. Cambridge University Press. ISBN 978-1-107-01765-8. Dolgachov, Igor V. Iskovskik, Vasily A. 2009. Finite subgroups of the plane Cremona group. Algebra, Arithmetic, and Geometry. In honor of U. I. Manin. Volume I. Progr. Math. 269. Boston. M.A. Birkhauser, Boston. pp. 443-548. DOI. 10.1007-978 so 81764745-2_11. Mr. 2,641,179. Gizatulin, M. K.H. 1983. Defining relations for the Cremona group of the plane. Mathematics of the USSR Izvestia. 21. 2. 211-268. DOI. 10.1070 IM 1983V021N02ABEH001789. ISSN 0373-2436. Mr. 675525. Godot, Lucien. 1927. Les transformations birationales du plan. Mémorial des sciences mathématiques. 22. Gauthier Villas ACIE. JFM 53.0595.02. Hayes-Winkle, Michiel, ed. 2001. Cremona_group. Encyclopedia of Mathematics. Springer. ISBN 978-1-55608-010-4. Hayes-Winkle, Michiel, ed. 2001. Cremona_transformation. Encyclopedia of Mathematics. Springer. ISBN 978-1-55608-010-4. Hudson, Hilda Phoebe. 1927. Cremona Transformations in Plane and Space. Cambridge University Press. ISBN 978-0-521-35882-8. Reprinted 2012. Semple, J. G. Roth, L. 1985. Introduction to Algebraic Geometry. Oxford Science Publications. The Clarendon Press, Oxford University Press. ISBN 978-0-19-853363-4. Mr. 814690. Serra, Jean-Pierre. 2009. A Minkowski style bound for the orders of the finite subgroups of the Cremona group of rank 2. over and arbitrary field. Moscow Mathematical Journal. 9. 1. 193-208. ISSN 1609-3321. Mr. 2567402. Serra, Jean-Pierre. 2010. Le Groupe de Cremona et ses sous-groupes finis. PDF. Asterisk. Seminaire Bourbaki 1000. 332. 75-100. ISBN 978-2-85629-291-4. ISSN 0303-1179. Mr. 2648675.